So I want to show the reaction that's showing on the right hand side of the screen, and then I'm going to jump over and show a simulation with it so you can see what happens. And you can tell on this side I have 2 molecules of NO2. And so what that means is that I have more of these molecules that can hit to the side versus this for every reaction. So if I'm on this side and I've got a certain amount of space, I potentially can have twice as many collisions with that side just because I've got 2 of them, versus with this one I've just got 1, so I can only have 1 collision. So you have to imagine this being scaled up by hundreds and hundreds and hundreds, so you can actually imagine there being some pressure generated. So the deal is that if you increase the volume, basically you're making a lot of space, and that makes less pressure because more volume means that there's more space to move and you're not going to hit the sides very much. Less hitting the sides. So in that scenario, it's going to be more comfortable or just as comfortable to be on this side because you've got more things that can hit the sides. You've got 2 for every one on the other side. And then on this one, if you decrease the volume, that will increase the pressure, which means more hitting the sides. And so that just means for this NO2 over here, this guy, he is going to be a better configuration because you've just got 1 thing hitting the side instead of 2 for every one of those. So let's see that happen. Remember, with decreasing volume, it means that we're going to, if the gas is in a syringe, we're going to make it a smaller amount in the syringe. We're going to squeeze the syringe. And then increasing volume, we're going to pull out that syringe. So here we go. Now I'm going to make it, the top one is all the N2O4. So I've got 5 things hitting the sides. And then now the bottom one, it's twice as much. So there should be 10 things in there. And you can see that, you can just look at that and you can tell I've got less things hitting the side, even though I've got twice as many little atoms in there. So if we mess with the volume, you would expect that the thing with, if I make the volume in this one smaller, you would expect that those will start joining together so we have less total collisions. So you can watch that happen. So there's one just popped together. There's another one. There's another one. So now we're down to 1, 2, 3, 4, 5, 6, 7 collisions. We keep going in. So you can see now the top is kind of conserving the number of collisions just because there's less, and then we can get it all the way in. And then likewise on the top one, because these are the same container, I know it's really the same, but on this top one, this is all the N2O4. So again, if I open up the volume, you can see that it's more comfortable now. They can shift back into that smaller position so there's less collisions going on.